Hello, my emerging mathematicians. I am Tamisha Johnson. I am the K through 12 Content Mathematics Director at the Mississippi Department of Education. Today, we will be doing a lesson on geometry, high school geometry, domain congruence. We'll be talking about standard 6, which is rigid motion. So welcome to A Moment in Math with Ms. Johnson. The Mississippi Department of Education vision is to create a world-class educational system that gives students the knowledge and skills to be successful in college and the workforce, and to flourish as parents and citizens. The mission is to provide leadership through the development of policy and accountability systems so that all students are prepared to compete in the global community. The State Board of Education lists 6 goals as the strategic plan. 1 being all students proficient in showing growth in all assessed areas. 2, every student graduates from high school and is ready for college and career. 3, every child has access to a high quality early childhood program. 4, every school has effective teachers and leaders. 5, every community effectively uses a world-class data system to improve student outcomes. And 6, every school and district is rated C or higher. Again, our lesson today is high school geometry, domain congruence, standard 6, which states, use geometric descriptions of rigid motions to transform figures and to predict the effect of a given rigid motion on a given figure. Given 2 figures, use the definition of congruence in terms of rigid motions to decide if they are congruent. As you see, I have highlighted rigid motions, congruence, or congruent. What are our goals for learning? We will understand the term rigid motion. We will understand the term congruent or congruence. We will review rigid motions or rigid transformations in Desmos. And we will use a sequence of rigid motions to determine if 2 figures are congruent. The standards for mathematical practices that we will be focusing on today are Standard 3, which is to construct a viable argument and critique the reasonings of others. So basically, we're going to talk about it and justify our thinking. Standard 5, use appropriate tools strategically. So we'll be using Desmos, and if you want to go ahead and grab a laptop or your phone, and we're going to use Desmos geometry tool, which can be found at desmos.com/geometry. We're going to look for and make use of the structure as well. Let's start with a rigid motion. What is a rigid motion? A rigid motion is a transformation that yields an image that preserves the side lengths and angle measures of the pre-image, and a pre-image again is the original figure. And from that transformation, you create a congruent figure, and we'll talk about what congruent means in just a minute. So here you see my pre-image, and you see my reddish pink pentagon. All right, that's my pre-image. The image is the blue pentagon. So if I were to move the pink or reddish pink pentagon directly on top of the blue pentagon, it should cover it fully. So if all angles match and all side lengths match, that is congruent. So the transformations that yield congruent figures are reflection, rotation, translation. Now these you've probably heard in 7th, 8th grade, especially 8th grade. And it was part of the geometry standards for college and career readiness in the 8th grade curriculum. Congruent figure. So congruent figures are images that have equal corresponding side lengths and angle measures of the pre-image or the original figure. So again, you see my pre-image. This is a regular pentagon. Regular means that all the side lengths are the same and all the angle measures are the same. So this is a regular pentagon. And if I, again, move it directly over this pentagon, it covers it completely. Okay? Remember, congruent means same angles, same side lengths, same shape. So in order for us to really understand congruent or rigid motion, we have to understand a non-rigid motion and what's not congruent. So a transformation that yields an image that does not preserve the side lengths of the pre-image or original figure creates a similar figure. So similar meaning it's the same shape, but it no longer has the same side lengths, okay? So here you see my original image, my pre-image, and here you see the image. What happened to it? Right, it's smaller, it's smaller. And because it's smaller, it is a dilation. And a dilation is a scaled image of the original figure. So if I was to take this dilation, this image, and place it on top of the original figure, you notice that the shape is the same, but the size is different. So because the size was changed, it is not rigid, meaning it does not hold its shape, okay? It does not, it gives. So if you think of the word rigid, rigid means hard and you can't move it. So if you think of something that's non-rigid, that means that it can be moved. So rigid holds the shape, non-rigid does not hold the shape. So let's talk about the congruent symbol. The congruent symbol is made of two parts. The first part looks like a little sideways S, a little curvy line, and that's called the similar symbol. So when you see that symbol by itself, that means that two shapes are similar, meaning same shape. Okay? Again, same shape, but not the same size. Equal. Now we've seen equal since first grade. We've seen that sign since first grade. Or we can say equal, or we can say equivalent, but that basically means it has the same measurement. It's the same measurement, okay? But when we join those two together, we get the similar, meaning same shape, and we get the equal, meaning same measurement. Now let's think about the measurements involved in a shape. Well, you have angle measures and you have side length measures. So all of those would be the same. Okay, so now let's look at a congruent statement. So this is read as triangle ABC is congruent to triangle DEF. So here I have a visual of the triangle, okay? And you'll notice that side length BC has the 1. Side length EF matches BC. Side length AB matches DE. Side length AC matches DF. They are congruent. Also, angle A matches angle D. Angle B matches angle E, and angle C matches angle F, meaning they are congruent. So what if I don't have these pictures? Well, I can figure out what's congruent simply based on the name. The name has the points in a certain order: A, B, C, D, E, F. What that tells me is that angle A is the same as angle D, and angle B is the same as angle E, because they're both second. And angle C is the same or congruent to angle F, because they're the third listed. Line segment AB, because they're side by side, is the same or congruent to line segment DE. Line segment BC is the same as line segment EF. They're congruent. And line segment AC is the same or congruent to line segment DF. Let's look at rigid motions. Now, rigid motions are also known as isometric transformations or rigid transformations. Rotation is something you may have heard of. Some people refer to it as a turn, but the correct mathematical terminology is a rotation. And a rotation is a transformation which moves or turns a figure about a fixed point, which is, we're going to call C, which is the center point or the center of rotation. The center of rotation is not always the origin on a graph. So it is important that you notate that center point. So rotation notation is the capital R, comma, the center point, parentheses, the center point, comma, the degrees of rotation, close parentheses. So for example, you have a capital R. I'm using O because my origin, for origin, and 180 degrees because that's the degrees of my rotation. So here, let's go to our Desmos geometry tool and watch a brief tutorial on how to create a rotation of a figure.
For this tutorial, we're using the Desmos geometry tool, which is new to Desmos. As you can see, I have already constructed a triangle ABC. It's labeled, and you can see line segment AC is 5 units, line segment BC is 3 units, line segment AB is 4 units, and on the inside it shows the area of the triangle, which is 6 units. Angle A measures at 37 degrees, angle C measures at 53 degrees, and angle B measures at 90 degrees. So for this one, I want to do a rotation of 180 degrees. So I'm going to move from construct to transform. I'm going to define my transformation. I want to do a rotation. I'm going to select my center point, and I'm going to change the angle measure to 180 degrees. Then I'm going to select the triangle that I want to rotate, and I'm going to apply. So now I'm going to go back and select this triangle, and I'm going to go back to the construct, and I'm going to change the color, and I'm going to label. Okay. So now, as you can see, angle C is 53 degrees, which makes it congruent to angle F. which is 53 degrees. Angle A is congruent to angle D, and angle B is congruent to angle E. Line segment FE is congruent to line segment CB. Line segment FD is congruent to line segment CA. And line segment ED is congruent to line segment BA. So even though I rotated my figure, it is still congruent, which proves that a rotation is a rigid transformation. For this tutorial, we're using
So now let's look at a reflection, which you may have heard as a flip, but the mathematical term is reflection. A reflection is a transformation in which all points of the pre-image has a mirrored or flipped image that is equal distance from the line of reflection or line of symmetry on the opposite side of the line. Reflection notation is the small r, where x is the line of reflection. So you'll have a lowercase r with subscript of the variable of the line. So if I'm naming my line x, it would be r subscript x. So now let's look at a tutorial in Desmos Geometry Tool on creating a reflection. And let's look to see if this is also a rigid motion.
For this demonstration, we're going to do a reflection of our triangle. So again, it's already been constructed. We're going to go to Transform. Let's define a transformation. We want a reflection. It's going to ask us to choose a line of reflection. Let's choose this one. Now it's going to ask us to select the object we would like to reflect and apply. Let's go back to Construct, change the color, and label. Now with the reflection, this is our line of symmetry. So we are 1, 2, 3, 4 units from the line of symmetry, or you can call this the y-axis. We are 1, 2, 3, 4 units, again, from the line of symmetry. Let's label. Okay. Again, angle A is congruent to angle D. Angle B is congruent to angle E. Angle C is congruent to angle F. Line segment AC and line segment DF are congruent. Line segment AB and line segment DE are congruent. Line segment BC and line segment EF are congruent. So even though we flipped or mirrored or reflected our figure across this line, it is still the exact same figure, having the exact same angles, angle measurements, and the exact same side lengths, which means it is still congruent and is a rigid transformation.
Now let's look at a translation, which you may have heard of as a slide. But again, the mathematical term is translation. Now, a translation is a transformation which moves or slides all points of a figure the same distance in the same direction. Translation notation is the capital T with the subscript of the A and B, where A is the change that is made to the x coordinates and B is the change that is made to the y coordinates. So my example here I have is a translation of a positive 9, meaning add 9 to my x coordinates, and a positive 1, meaning add 1 to my y coordinates. So let's watch a brief tutorial to see what happens when we translate our triangle, a positive 9, positive 1.
In this tutorial, we're looking at a translation. Again, I already have my triangle constructed. You can see the measurements of my sides, and you can see each angle's measure. So I'm going to go to transform. I'm going to define my transformation as a translation. It asks that I choose a point from. I'm going to move point A. Where am I moving it to? Let's choose this point here. Okay. Then I'm going to select the triangle that I wish to move and apply. Now I'm going to go back to construct, change the color of my triangle, and label. So here I have translated 9 units to the right, or a positive 9 on my x-axis, and 1 unit up, or a positive 1 on the y-axis. So as you can see, angle B is congruent to angle E. Angle C is congruent to angle F, and angle A is congruent to angle D. Line segment AC and line segment DF are congruent. Line segment AB and line segment DE are congruent, and line segment BC and line segment EF are congruent. So even though I translated this figure 9 units to the right and 1 unit up, it is still the same, exactly the same, or congruent.
Let's look at some skill practice. Here I have triangle ABC was translated 4 units left and 5 units down, creating triangle DEF. What is the measurement of angle F? Well, let's look at this. Translated means that it will be a congruent figure, because translation is a rigid motion, meaning that my shape may slide, but the angle measures will stay the same, and so will the side lengths. So given that information, if I'm looking for angle F is in the same place as angle C. So what is angle C? Good, 53 degrees. So the answer is 53 degrees. Angle C and angle F are congruent, meaning the same. Now let's look at one last. Triangle ABC was translated 6 units to the right, rotated 125 degrees, and reflected over the x-axis, creating triangle DEF. What is the measurement of line segment BC? Good, same concept. A translation is rigid, a rotation is rigid, and a reflection is rigid. So if BC is the same as EF, then BC would be a side length of 3. We had an awesome day today, and I hope you learned a lot about rigid motions and transformations. So I want to say good job, and I want you to go out and practice. Use your Desmos geometry tool and practice creating rigid motions. Today has been wonderful, and I look forward to seeing you next time. You have had a moment in math with Ms. Johnson.